Welcome back to our channel. Today we are going to discuss an important topic, securing your Kubernetes environment. We'll cover the top 5 best practices to ensure your Kubernetes cluster are secure. Okay. Agenda for today's video, we'll go through each practices step by step, explaining why it's important and how to implement it. Okay. So first one is image scanning for vulnerability purpose. So first step is image scanning for vulnerability purpose. Correct. So in this step, so for securing Kubernetes environment to scan your container images for vulnerability. Because of that, like in an image, we will mention too many parameters like from app, which app we have to run, like uh, like what commands we have to do, like too many things, that application file system things, some libraries are there, so many stuffs are there in a image. Okay, for to checking the security vulnerability purpose, so we have to do some image scanning. Okay, so why it's important? Containers can have vulnerabilities that could be exploited if not addressed. Regular scanning helps identify and fix those issues before they come problem. If once we created a container on basis of that, so we can't do anything. Okay, so that's why before creating container on the basis of that, so we do image scanning for security vulnerability purpose. For that, we have so many tools, like a Claire tool is there, that app scan is there, aqua security to scan your images is there. So that so many tools are there for doing. And by using this drive, like this is my image, latest image is there, so we can do some shell operation on it as well. Okay, and it in if we are means in continuous integration, we can include this image scanning process as well. So here you see, integrate image scanning into your continuous integration and continuous deployment pipeline to ensure all the images are scanned before deployment. So if we had done the scanning, image scanning before the deployment, so it ensures the quality of our CI workflow. Okay, CI CD workflow. So, okay, so first point is do image scanning for security vulnerability purpose. Okay, and second one is avoid a root user for running a containers. If there is a container and we are running a container as a root, it is a significant security risk. Because of that, the root user have so many accesses, and it attached to the so many permission. So because of that, if an attacker gains access to the container running as a root, they could potentially gain a root access to the host machine. Okay, they are able to gain the access, like if there is a admin server and which 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 hosts the too many managed servers, like which contains that managed three or four managed servers are there, and which have so many JVM, so many applications running in it. So because of this, so it impacts, like attackers gain access to those server as well. So because of that, we have to make sure that the running container as a root is we have to avoid the root user for running a containers. We have to avoid the root user access. Okay, and how to implement it? So by like ensure, why whenever we are creating the users in a Docker file, we are mentioning the users access roles and like in a Docker file. So there we need to mention like ensure your Docker file specifies a non-root user. Means inside that Docker file we have to mention this for specific roles we have to mention non-root user. Okay, for running a containerization, those the guy who is running the containerized application. So for who that one is non-root user guy. Okay, so here you see like one example is there from Alpine run add group hyphen s app group add user hyphen s app user hyphen j app group. So this is one of the we have added one like non-root user. So by this way we can do from Docker. This is a Docker file. Okay, here we have used the keywords like from for running application like user which user app user. Okay, like that. This for security contents use Kubernetes security constraint to enforce non-root user. Okay, this increases the Kubernetes security. Okay, because of that. And in Kubernetes as well. So this is a YAML file. Okay, and here also here kind. So here name non-root pod for specific container. So here also we have mentioned the non-root user. Correct. So like this. So second point is what? So we have to make a Kubernetes secure. We have to avoid root user for running a containers. Okay, got understood. And third one is like RBAC means manage user and permissions. Like we have to this is a role based access control means we have like it is a role based access control is essential for managing permissions in Kubernetes. Like in a Kubernetes so many components are there like etcd is there, that clusters are there, that pods are there, so that kubelet is there, kubeproxy is there, so many components are there. So we have to manage the users and permissions in it. So for that, why it is important? Rollback role based access control ensures that users and services have only the permissions they need. The following principles of at least privilege. Okay, means at least privilege means if the guy is doing only the deployment in a some cluster, so they have only the that role is binded in it. So like that way, like here you see roles and role binded. So define roles and bind to grant the permission. Only those things like he's working on one of the cluster. So only that clusters have he has the permission and attach the role in it. So like that we have to do the like oh here you see one YAML file is there. So on the basis of that we have to attach the roles in it. Okay, so here RBAC authorization dot like role name is pod reader. Only if the some guy is doing some so means like if there is a fresher join in a team and they have to do some operation, so for that purpose we'll assign like a read only permission there, like that pod reader role is there. So like that. So this way, so by using managing users permissions and accesses, so and users will make do Kubernetes secure. Okay, third one. And the fourth point is using a network policies or service mesh. Using a network in this video, just understand network policy. So using a network policies, we can make Kubernetes robust, like secure, much more secure. So network policies controls the communication between pods in your cluster. If in a cluster that too many pods are there, like 4 or 5 pods are there, like which has some managed servers in it. So to communication in between the pods, so we have some network policies like have some ingress control, like TLS is there. So like that, ingress is there, egress is there. So like this, so many policies are there which restrict the traffic. Okay, so why it's important? They help isolate workloads and prevent lateral movement in a case of breach. Means if in case of like if there is a application server is there and we want to, if there is a pod which contains application layer, another pod is there for database layer, and another is for uh, like or like deployment is there here. Okay, application is running in it. Okay, so we, if one guy has access of this pod and this one is another, so after application layer, so the data is transmitted into database layer, and then in a, okay, so here also running that application in it. So for that, like if the networks are configured in this way, like the first it goes from app to db to that server, so like this. So how to configure accordingly, that how the application flow it is. So on the basis of that, we have to configure the network policies in it. Okay, define network policy to restrict the traffic, like okay. And in a YAML file, we have to define the network policies in it. Okay, like here policy types is ingress, so egress. So like that, we have to mention the which network policies we are using, and on the basis of that we have to specify some parameters and we have to use in it. And we have to, by using that, we have to make our network policy strong and make a Kubernetes secure. And the fifth one is encrypt communication. Okay, so how we can achieve the encrypt communication? Encrypt communication ensures the data privacy and integrity. Okay, it ensures the data privacy and integrity. So why it's important? Sensitive data transmitted into a plain text can be intercepted and read by attackers. So because of that, it is important. Sensitive data, like that pod contains so many data in it, like so many data, the pod related data. So all the data which we stored in a where in etcd component, which are one of the component of Kubernetes. So where we store all the sensitive data in it. So we have to make secure that. So for that purpose, so we'll use here TLS for ingress. Use TLS for securing traffic to your services, and also for encrypting at etcd, means ensure etcd data is encrypted at rest. Means yeah, in a pod that too many data is there, that application data file system is there, library files are there, to what which pods, which servers are running, like all the stuffs are there in a etcd. Okay, so by using TLS for ingress and using encrypting to the etcd, we ensure the etcd data is encrypted at rest, and this way we secure the Kubernetes cluster. Okay, so for securing your Kubernetes environments involves multiple layer of protection. By following these above practices like scanning images, avoid root, managing permissions with RBAC, using network policies or services, and encrypting communication, you can significantly enhance your cluster security. Okay, if you find this video helpful, please like, share, and subscribe to our channel. For more DevOps and Kubernetes tutorial, leave your questions or comments below. We'll see you in next video.